Hey everyone, this is Jan from STEAG, and in this quick video I would like to show you the workflow in our predictive maintenance system. So from the starting point where you receive an alarm via the process of analyzing it, and then basically new steps that have to be taken after that. And what I would like to show you that you don't really have to be a data scientist or have to have deep technological knowledge to do this first quick analysis. So let's get going. For that, I would share my screen so you can see where we start. Okay, what you see here is the email that you would receive from the system. So at the top of the email, you can directly see what is the problem here. There's a bearing vibration that is too high. In this case, it's IDF, it's an induced draft fan. So if we scroll down a little, we can see here the signal over time of this KPI. So it's in a regular mode for most of the time, so for several months. And then suddenly an alarm pops up here, indicated by this red dot, which you can also see the explanation here that yellow is basically an event or warning, and then an alarm. And you might wonder why there's not an alarm directly for the first point here. So the system first needs to verify via several statistical methods that it's really reliably an alarm, so that you don't get any false alarms just by a one-time peak, for example. Okay, there's much more information here in the email, but we don't want to go into the details here, but instead jump right into the system itself. So here you can see the portfolio view of our predictive maintenance system. As you can see, it's a browser-based system. So basically people from site as well as from the central team can access this. And you can have different assets in here, and by the colors green, red and yellow, you can already get a first glimpse of the health status of the overall asset. So since we have a very generic system here, it can be a coal-fired power plant, it can be a wind turbine, but of course it can also be a hydro plant or even a PV plant. So we received our alarm from this coal-fired section here, and what we can see in the cockpit now is the asset view with the different groups of, let's say, the feed water pump, the turbine, a forced draft fan, air preheater, and also the induced draft fan that sent us an alarm. So if we look into the KPI view, we can see that most of the KPIs are in good status, except for this one, which was the one highlighted in the email. So if we open that up here, right at the top, we can see what the history of the alarm is, which is typically the first point that you want to have a look at. Was there something similar in the past? And we can see that there's no critical things basically, except for the two warnings here. And then the latest point here is at end of June, there's the alarm. And as you can see here, this is the first alarm that we also received via the email. You might wonder why there's more data in here now than in the email. And this is because we did a post-mortem analysis. So we analyzed the data after the incident happened. So you could, but what it shows very nicely is that the problem didn't resolve itself, right? So action needs to be taken. So now we've seen the alarm, we have been notified, we've somehow verified that it's the first time that it happened. Now, the next thing that we do is typically we have a look at the input signals that are used to calculate the alarm. So this can be rounds per minute in this case, or a pressure before and after the fan, basically physical signals going into the calculation. And first, of course, you always have to verify if the input signals are valid, so that there's not a sensor problem or anything else. So this can also be done either manually in our system or automatically via a third-party system like the one from Aperio, which automatically verifies that all the input data is correct. So in this case, you could skip the step of verifying the inputs and go right to action. And to support the workflow and also ease the communication between different parties, we have the journal here. You can see some journal entries. I have to excuse, some of them are in German. But what we can do now is basically we can create a new journal entry, and there are different categories of journal entries. And what we would like to do now is we want to send some information to the site. So let's say we are not on site, but we've recognized the first alarm, and we will just say, please check bearing during next maintenance period. And then we confirm it, and we can see that it pops up here. And now, of course, the on-site team would also automatically see it in the cockpit, and after the maintenance, they could reply here. And you can see the journal would thus work as kind of a workflow management system, but as well as a knowledge database. So then obviously next time something would happen with the equipment, you would see all the history and all the information in there already. Okay, that was it already. I hope I could show you that you do not really have to be a data scientist to analyze the first alarms in our predictive maintenance system and to give you an idea how it works in a day-to-day operation. So I hope you liked the video, and looking forward to discuss with you further in the future. And thank you, bye-bye, and have a good day.